Can we get some feedback? Whether
Hi everyone.
Audible?
Yeah, how do we sound? Hello everyone. Hello Bettina.
Sounds good to me, but can
good
anybody
to me.
hear?
No echo of everything. Okay, somebody told us we
Perfect.
are good on the chat. We can start.
Excellent.
All right.
Wonderful.
Perfect.
Welcome everybody to our introduction to Cassandra for developers. And very nice to see you and have you here this evening, this night, this afternoon, or this morning. I don't know from where you're all dialing in, but it's lovely to have you. And today I'm Bettina Svennerton. I'm going to be the main presenter. I've got Cedric with me, who is hosting and who's helping out and cutting in and interrupting me whenever I say something which isn't quite correct. That would be wonderful.
I don't do that.
But in the background, we've got a whole host of people as well helping out, answering questions on YouTube and on Discord, and I think definitely we have Jack Fryer there. We have a couple of other folks from DataStax helping out because we're actually running another workshop in parallel today. So we have no David or Eric this evening or this morning. But yeah, bear with us if we don't get to all of your questions in time, but Cedric will help me read them from YouTube and from Discord, and we can also answer them during the video.
Yeah, I will be the gatekeeper for today.
Yes, please, that would be wonderful. Okay, cool. So we are streaming on YouTube and on Twitch. We will not be monitoring the chat on Twitch. We will only monitoring it on YouTube and of course in Discord, right? So Discord has, you can write more, right? You can use Markdown, you can write more, more interesting messages probably, and we can get back to you later on. It's much easier than YouTube. So it's your choice where you want to ask your questions.
Yeah,
and this is a hands-on. Yeah, hang on.
No. I say on Discord you can one-to-one conversation is easier than YouTube chat that tends to go too fast. Yes, and
exactly.
It'd be good to be part of the community. Oh, do you know how many we are on Discord? More than 6,000 now.
Oh my God!
Not at the moment, but overall in the community.
Yeah, Discord is on all the time as well, not just doing this video, right, or doing this workshop. So if you have any questions outside of this workshop, you can always ping us on Discord. There are people, everybody's checking in occasionally during the day, so we'll catch it. Today is a hands-on workshop. We really, really want you to use it at the same time as us. We will give you time, right? So we will not go at very fast speed. It would be absolutely wonderful if you coded along, if you tried it at the same time as we do. And we will be using Astra, right? So you don't need to install anything. There is, you can just sign up there and then. You don't need a credit card or anything. It is available in your browser, so you don't need anything special. But you need to have an internet connection and you need to have a browser, okay? And of course, we do quizzes with Menti. So if you haven't been to any of our workshops before, we'll give you a code in a moment. And you would go to menti.com with that code, and then we can ask you a few questions about yourselves. And later on, we will ask some quiz questions, and there will be prizes. So those Menti quizzes are very, very popular, and you need to be fast in order to get to the top 3 who win the prizes, but more on that later.
Yeah, let me drop the link Menti on the YouTube now. And if you're on Discord, there is also a link on the main chat banner where you can click on the Menti link as well.
Cool. But it doesn't stop there, right? So we have the DataStax community, which is always on, which is served by lots of people within DataStax, a lot of Cassandra experts, and also community users, those who've gone through the certifications and have done a lot of studying, they're also helping out answering questions. So if you have detailed questions that require sort of log snippets or error messages, or really, where we would need to give you a detailed how to answer, please go to the community because it's then there. It's available for other people. Other people can comment and learn from it. So it's a really nice way of communicating your technical questions. And then, of course, we have the Academy, right? If you want to take it further, you can take courses, both for developers and admin, and you can work yourself up to certification if that's what you want to do. So there's tons of video content there, also the quizzes, everything that sort of leads you up to certification, but also other stuff, about how Kafka and all these kind of things. And we have the Discord chat, before we introduce that. So please use that. That's really good. Cool. So should we launch right in, Cedric, or do you have any more comments?
No, I think we are good. So far, so good. People just saying hello from everyone over the world. Love that, by the way. Yeah, so pretty happy. And we are about 125 at the moment.
Oh, cool. I think you have quite a few people from India, right? They must be really late right now. So thanks very much.
Yeah, thank you for joining, even if it's late for you.
Midnight oil. It's really late. But there's also a session tomorrow with the same content, which is a little bit friendlier in terms of time.
I think it's 3 hours before.
Yeah. Okay, so a few words about Astra, right? So it's the easiest way to use Cassandra available to you. It's available without any cost. You can just sign up to it. You don't need any credit card. There's a very generous free tier. And you do not need to care about installing Cassandra. So you can and you do not need to care about operating Cassandra or administrating anything. It's just there, available for you to use, and we will use it today in the workshop. So you literally have no excuse not to do it without.
Yes.
Right? So you do not have to go and provision an instance and install the database and bring it up and make sure everything is working. It's all there. It's hosted as a service for you. And it is available for everybody with a very generous free tier, so there's no cost.
Yes, and so it's software as a service, but not only it's free tier, but there is absolutely no credit card whatsoever to run the database. And so it will be all based today, nothing to install and all free. So yeah, no excuse.
Yeah, exactly. No excuse. You need an email address. Sign up, but that's it, right? And Astra is, it's a new offering from DataStax. How long have you had it? About half a year, I think. And it's Cassandra as a service in the cloud. It's on a truly global scale. So it brings you the same advantages that you would expect from Cassandra. And what we think is the reason why you're attending the workshop today is that because you're interested in Cassandra, its scalability, its performance, its availability, its accessibility, right? It's all that. You get that with Astra too. But it just sort of takes away, it's provided to you as a service, it takes away the operational overhead, which, I'm sure if you've played with Cassandra or used it at work, you might appreciate that. And, as we said, we have a free tier and it's 10 gigs, so you can actually probably use it with quite a little bit of data. So,
yes.
Cool. So let's go to Menti. So for those who are new, I show you, let me see that I can get actually to the right, I need to present that. Mm-hmm. Wonderful. So if you either put the code in 7048439.
Put the code once. Let me put it back here and also on Discord. Here we go. Perfect. And if you rather click on the link, here is the link. I will do that in the meantime. So the QR code you are seeing.
Thumbs up whether in there.
Yeah, and give it some send up in.
Oh, I see some people there coming in. That's wonderful.
Yes.
So this first round of Menti, this is not challenging at all. This is really for us to get to understand a little bit where you're coming from and what your expectation is. And so we can judge sort of like whether we get it right for the right audience. So the quiz is coming later, right?
Yes, games, swag and everything later. Now it's simply survey.
And it's Menti test, so you can check how quickly you can get to the slides. So, because later on you have to be fast in order to win the prizes.
Yeah. Okay, so. And we ship everywhere in the world.
Okay, so just a few questions. How much experience do you already have with Cassandra? And wow, cool, never used. That's what we want. We want to really introduce it to new people.
Yes.
And that's really cool if we have really newbies. We have someone 3 to 5 years. That's impressive. So please answer questions. we hope that you will be able to answer the questions for your fellow workshop attendees in the YouTube chat and in Discord.
Yes, never use it. That's perfect. You know, Astra is also all about that. It's really about getting started with your database you never knew. And you will see that it's pretty easy, pretty close to SQL to interact with. Yeah, we'll discover that.
You know, Cedric, next time we need to have something like more than 10 years to sort of like catch all
Oh
those
yeah,
people.
true. Cassandra has been created in 2008, so it's 12 years already. Wow.
12 years, okay, perhaps something like more than 15 years, because
yeah, but you know, the Cassandra from 8 years ago has nothing to do with the Cassandra of today, you know.
I know, absolutely.
Now the Cassandra 3.x is GA for the while, and we really expect to have the 4.x coming this year. There is already a beta 2 available now.
Yes, and that's going to be really exciting. So you want to stay tuned, right, to our YouTube channel, etc., because we will have content later about Cassandra 4, which is, you know, a big improvement and a big evolution. And so we're all very excited about that. Okay, cool. Oh, we've got 66 now on there. That's nice. I think I'll just go off to the next one. Have you been to any of our workshops before? Wow. Or new people.
Oh, great. That's great. Yeah, just for you to know, it's a workshop, I think, number almost 40 now. But that's very cool to have new people. And I can see it's very interactive with Menti, with exercise. You don't install anything, and it's only 2 hours.
And we've had a few people coming back again and again to the introductory workshops, right? So as today, so thank you very much for coming, right? Mm-hmm. If this is, if you sat through this 2 weeks ago where we did exactly the same, I hope you still find it interesting, right? And I hope you still like to play along. And yeah, but if you already know some answers, you know, help out with your fellow attendees. That would be really awesome. Mm-hmm. Cool. What's your main motivation for learning about Cassandra? That's always so interesting to watch.
Yes. Both dev and admin, sure.
And actually, that's a picture that we're seeing pretty much. It's so equal between, so a lot of dev people are also interested in the administration of it.
Yeah. So for 3 people only interested in Cassandra, administration of Cassandra, so today it will be software as a service, so not a lot of administration, but still in the same YouTube channel, now all the courses from DataStax Academy has been released. So you can browse the video and you can find a playlist named DS210, where you do have about something like 10 hours about Cassandra administration, and it would prepare you for the certification, maybe.
If that's why you're interested in it. Today we will go as far as the SQL console, so that's as much as you get into you know, practicing Cassandra. But not further, right? So if you're interested in administration only, then you know, it's still good to know a little bit about, you know, the site, how developers would use it, right? I think it doesn't hurt. But,
yes, and what you should consider when, you know, you get a project to put in production, just to be able to, you know, scream after developer that did not implement the data model properly.
Yes, exactly. You didn't data modeling guidelines. So, how did you hear about this workshop? So, I thought I had a lot more choices on this one. I'm sorry. I thought that Facebook and Eventbrite, etc. But that's and you should have another column as well. Okay. So. But Instagram is popular. I saw that.
Yeah, Instagram is a thing. I'm pretty too old now. I don't even have an Instagram account. Should I say that?
Yeah, I'm the same. The through a friend is interesting for us. You know, if you want to tell us your story, so hit us up on Discord and tell us, you know, who recommended. I think that's always good for us to hear as well. We like to hear that.
We're always looking for testimonial and way to improve.
And what are you planning to do with your new knowledge? you want to get a better job, better understanding generally, build an app. Oh, that sounds wonderful. Cool. Yeah, again, we want to hear your stories there. So what's the technologies you're going to use, you know, what languages you're going to use, what stack. That sounds all really interesting. Cool.
Build an app. Okay, great.
Yeah,
and
cool.
you know what? So today is all about the proper data model and, you know, doing your first queries. Next week, we will build an app using the Java technology on top of what we have done.
Exactly. So come back if you're interested in building an app. Come back next week and learn it with Java and Spring.
Yeah, but you know, we do have a lot of sample apps available on GitHub. So if you're really interested in that, yeah, pop the question on Discord. I will share you the link.
Yeah, of course. I think we might actually touch on it later as well. So cool. Well, thank you very much, guys. So let's go back to the actual presentation. Thank you very much. And we start with a bit of hands-on, right? We want to make sure that we can all get to a running Astra instance. So that is the very first one. So let me first perhaps show you the GitHub link.
Let me copy the GitHub link in YouTube and in Discord. Done.
That should be, how is that for reading this?
I think it's big enough.
Okay, excellent.
Even if I'm old, that should be cool.
So even with my eyes. So this is the GitHub, and we have everything in here. If you want to, first of all, I think we get this question a lot. All the workshops are recorded. They will be staying on YouTube. So if you want to review anything and if you want to come back, you can always come back. You can also review the slide deck, and then you know we have the exercises really laid out with a lot of screenshots. So if you don't want to do it with us now, you can do it later. You can do it later at your own leisure, or you can do it with your friends, or with your college, or you know, with your team, wherever. Okay. So now we want to create. Let's go back to the first exercise. We want to create our Astra instance. So you go to astradatastax.com and register there. And if you haven't done it yet, so you can just sign up with an email, or you can use your Google account or your GitHub account.
GitHub, that's pretty neat. You know, click the GitHub. Most of the time you're already signing on GitHub, so that's a single click.
That's very useful, especially if you use other things like Gitpod. It's useful to have a GitHub sign-in, right, to be able to log in. And so you should come to something like this. Let me just make this a lot bigger as well.
Yes.
And so you have a lot of choices there and we give you some recommendations today how to set it up, but you don't have to do that, right? So you don't have to follow those steps. But we basically say here, of course, we want you to choose the free tier, right? Choose a region that's close to you. I think for India, it's still closer to go for Europe West, right? The other alternative is US East. And then we use these details for the database name. So we killer video cluster, we use the key space, killer video, we use this username KV user and KV password, which are obviously not very secure usernames and passwords. But for the purpose of this exercise, you might just want to follow along that you have to, you know, later and you can just copy things. But it doesn't really matter what you choose there, right? So it's but I will be using this. So basically, I created the free tier. I need to select the region. So I go for Europe West, and I go for the database name. So killer video cluster. What's that? And then KV user, KV password is probably already in there because that's basically what I use all the time.
Yes.
And then they need to match, otherwise you sort of like there. And then you launch the database.
Yes. And
then
okay, you just launch. But so if you see, we pick the free tier, and this is why you only have 2 locations. But if, you know, for instance, you pick any of others available, you can see that this database can run on GCP, Azure, AWS. So you pick the cloud provider you want the database to run. And you can do what we call VPC peering to make the DB part of your existing cloud infrastructures. Okay.
Ah, that's so cool. Yeah, exactly. So, right. So, yeah. Thanks so much, Cedric. I should have shown that. Yeah, I think I cannot get to this now. That this
no
is,
problem. But, you know, just because it took a few seconds to be ready. If you click now on View Database, you will see a green banner on the top during the database initialization. Totally expected. It's done already.
It's already done. It's already done, and this is all there. So now I think we just give you 5 minutes to do this yourself, and then you get give us some thumbs up when this is done. And Cedric, you could play some nice music, right? So to entertain our
Let's see.
Can
why
you?
do
that
I
would be
have?
Wonderful.
Yeah. Let's see. I will try to run this. Hope it's not too.
Yeah, I probably won't be able to hear it.
Yeah, probably not you. I'm not sure on the YouTube if it's going through.
Losing out. But obviously I want to know if there's successful database creations or if people have any problems doing this. I rely on you, Cedric, to propagate this information because I'm not seeing the chat.
Oh, I already see 2 people done, 3 done. I think we do have the good pace, you know, during the time you enter your credentials. Good to go too. So let's see. Really nice music. You can tell the name of the song. So the music come through.
Also the music, what are you playing? Because is it some of the DataStax radio?
No, it's not. I use some OST of a very old Miyazaki movie, which is my Yamada.
Let
me
Studio Ghibli.
Yep.
Okay. Yeah, my favorites as well. So that's great.
Yeah, and this one is not very famous, and it's a shame because it's very funny. Yeah.
Which one is it?
It's just looking. It's okay. Let me see. My neighbor Yamada. Yeah, but I know the title in French, and it's always difficult to translate that. So what is the original title? Looking for the English name. But that's my Yamada neighbor, something like that. 1999. I told you I was old.
So how we doing? So is everybody done?
My neighbors, the Yamada. Okay, I got it. Free tier. Which compute site do you need? Yes, please, free tier. The first one, totally free. Because if you pick one or the other one, the launch database button will change in give me your paid information, how to pay it. So no, we want that to be free.
So you should come to you're all done when you see the connection details and you see the REST API and the GraphQL API links. You're all done. Done.
Yeah, I think. See the number of views I've now jumped. That's cool. Done. Yeah, good feedback. Yeah, keep providing feedback that you are done. We really love interactivity, as you may notice. See, 1 minute and 30 seconds. You can still click it everywhere. As you can see on the UI, there is a REST API, GraphQL API, if you want, simply connect an app directly. But we can also use the drivers to connect to Cassandra and use the query statement. Yes. And what is very interesting for today is the Launch Now button, where we will launch the development tools, which is called DataStax Studio.
Oh, I won't.
Taking time in launching, yes, it might be the case because remember, you're all launching some database at the same time. It can take up to 5 minutes, even if it's only 10 gigabytes. We may provide you multiple nodes,
And later on, if you have problems, you can ask for help, right? If you use it on your own, and you can sort of like explore, you can chat to some people, you can explore, Astra on your own as well. And Cedric, I will be using the console today.
All right, totally okay.
Yes, but you can totally try that out on your own as well, the studio.
Okay, I do have Shivan who said he missed the beginning. Unfortunately, once you have created a DB, if you go back to the creation form, you cannot select the free tier, but can you try to go back to the list of database, Bettina, and see if you can, simulate database creation?
If you already have a database, you cannot create a new one.
But here, so click create new database. Okay, so this is there. So Shivan, this is the UI you should have now, and so you should have the free tier not disabled as here, because you can only have one free tier per account, and then you simply provide the values. And so killer video cluster, key space name is killer video, and KV user, KV password. All these values are provided in the GitHub repo, and I put back the link to the GitHub repo here. So you can catch up, no problem. I think
step 1B.
Yes, step 1B. We still have time.
Okay, perfect. So I think the timer's up. And
True.
Judging from the comments on the chat, do you think we can move on?
I think we can. I do have a lot of done, so let's move. And
perfect. That's so cool. Wonderful. Good. Okay. Well, thanks very much. That was the first exercise, and now we go into a little bit of theory, and then we try it out again in the database, and we create our own tables, etc. So, but let's talk first about the structure of the data that we will be putting into our database, right? And one of the most fundamental structure is a cell, right? Which is, we define it as an intersection of a row and a column. And we put the data in there. It stores the data. So this is really just going over the terminology. We're going to build up all the elements that we're going to be talking about. So the cell is in a row, right? So, or rather, a row is composed out of a number of cells, and that's a single structured data item in a table. And they're actually structured. So when we create the table, those columns, they will have types, right? So it's and they have names. And it's not entirely freeform, so it has a schema and has a structure. And so we will often be talking about rows in the concept of Cassandra. And a more important aspect than just rows is, and probably quite specific to Cassandra, is the concept of partitioning and partitioning your data and the partition. And that is a way of grouping rows by having the same partition token. And so the benefit of that is that you can then co-locate all those rows that are sort of grouped by this partition token onto the same nodes, onto the same physical nodes, which makes it very fast to get the data out of Cassandra. So that's quite an important concept, and we will be talking a lot about partitioning today and how to construct our table structure so that we have the optimal partitioning for our data. And then all the partitions and the rows and the cells, they all reside in a table, right? So this is, as you would expect from a database, really. And that's no different to, for example, SQL. So they reside in a table. We here have consecutive IDs, but that's purely coincidental. You don't have to have that, right? So actually, we do not have the concept in the Cassandra tables of having consecutive IDs, right? So there can be anything. And in fact, if you're using these as partition keys, there will probably be something different.
Okay.
And then overall, your table resides in sort of like a namespace kind of object, which is the key space, and which we created today with Astra. We recorded killer video, and all of our tables and all our data elements go into that key space. So that's basically the basic terminology in order to talk about data storage in Cassandra. Make sense?
It does.
Okay, so and just to remember that the partitions, they can span several rows, right? So the rows are the unique data records, and then the partitions sort of group them into several rows, into some chunks of rows, And it's a really important concept of Cassandra. So we will be denoting these chunks or partitions with the partition key, and we'll be talking quite a lot about that. It's part of the central elements, and we want to make sure that you really get that concept.
Yes. So question, can we only distribute data across nodes based on token range? And so the answer is yes, but whatever you put as a partition, it can be one column, multiple columns in the partition key, okay? This is a job of Cassandra to hash the value of the partition key to create this token and to distribute accordingly. What you simply need to understand is you store together in the same partition what you need to retrieve together.
Exactly. And we actually have a lot of examples about exactly that concept. So here's an example, where the users, with their names and their address and their email addresses, they're organized by city, right? So here, for example, for Phoenix, this is the partition key, and then we have all the individual users there. And now the query to ask, give me all the users in Phoenix or give me all the users in Seattle is really easy to satisfy. It just has to go to one space, to one node, get that data out, and it's all stored together consecutively on that node. So that's as you will see, this is the big advantage of partitioning your data in this way with the partition key. So this here is the overriding partition key, and then the rest, these are the individual columns. We're using something called here clustering columns, and we really go into the details of that as well. It just means to allow to express uniqueness of your data. So you don't, you have a unique row for your data elements, and then you have the additional data in there that belongs to that unique record.
Okay, question about the namespace. So namespace is really a logical grouping of tables. So then you can put some maybe security role-based access based on the key space and create user based on the key space. And also, technically speaking, at the key space level, there are some metadata. First metadata is how many times do my data is replicate? Because the data is distributed among the nodes. But what happens if you lose one of the nodes? It's not a big deal because the data is replicated multiple times. Totally fine with Cassandra. And you define that at the key space level.
And then, for example, you would have probably a different key space for each different application. So it's just for it's a namespace reserved for a certain concern, right? Or your security key space might have a different, as said, different replication in order to be available on a higher level. So it allows you to set certain parameters for this group of tables, that pertain to a certain application. Okay, so this is basically how the table creation looks in Cassandra query language, which is CQL, which is a subset of SQL or SQL-like. You cannot do everything that you would do in SQL. For example, Cassandra does not allow you to do any joins, but the create table statement is very similar. And here, this is the important bit where we define the primary key. In Cassandra, every table needs to have a primary key. And a primary key always has a partition key because you always will need to partition your data across all the nodes in your cluster. And then you have the additional elements in your key in order to ensure the uniqueness of your data.
Yeah.
But ultimately, this is a very simple creation statement, key space name, table name, the various columns with their types, and the primary key.
Okay, we do have a very good question at the moment regarding how to check if you have a huge key space. So it's so the key space, it's not really the issue here, it's the partition. What if you have a huge partition? I mean, you have grouped everything in the partition just to be sure to go to the proper node very quickly and read the partition. But now if the partition is big or all the data are in the same partition, you always go to the same node and you do have a hotspot. So that's your job as a data modeler to define a partition key that will evenly distribute the values in partitions. Okay, so like if you are using user by city, maybe city is not good enough for a partition, because if you do have too many people in the same city, 1 billion inhabitants for the city, yeah, it's too big. But then, because if you want to look for somebody, you will go to the city and you still have 1 million rows to browse just to see if you get the last name and the first name. So to avoid this big partition issue, you can add another column in the partition key. So you can add city and maybe neighborhood.
The district.
District.
Yeah, the neighborhood.
True.
Yeah,
and then
exactly.
you will break down the partition in multiple small pieces, easier to navigate.
But we come to all this, hey. You know, you don't have to do freestyling. We have slides for exactly that.
Yes. So question about clustering column. So still, I think you will cover that, but you can only query on column that has part of the primary key. So if you want to be able to query on last name, first name, they have to be clustering column. And also, you might notice that the partition key is not enough to ensure unicity of a record, because we have multiple records in the same partition.
That's exactly
so you add clustering column to be able to ensure that unicity. Okay, I'm shutting down now.
So that's fine. No,
I'm hijacking.
Exactly as Cedric said, the primary key ensures uniqueness. You know, it must ensure uniqueness, and we can give you some examples here what would happen if you don't do that, right? So you can start with a bad example here. So where the primary key is city, and it has then 2 clustering columns, one for last name and one for first name. So imagine you have the city of New York, and you have Adam Smith. Right. So, you know, I can imagine that we have more than one person called Adam Smith in New York. And in this case, they would all share the same record, right? So, for example, if you then updated the age for Adam Smith in New York, and next time you update it, you write something else, you know, for a different user, for a different Adam Smith, they would inherit the same age. So that's a bad example, right? Because you have a high chance that the names are shared. Right. So a slightly better example is where you would then roll in the email address as, you know, another parameter of uniqueness, right? So let's hope that all these Adam Smiths don't have the same email address. And then you can differentiate between them. So they all live in New York, they all have the same last name, and they all have the same first name, but they have different email addresses. And then you have a more unique record there. There could still be corner cases, right, with 2 Adam Smiths, junior and senior, living in the same house and sharing the same email address. But, you know, let's not go there today. Another good example is to just use a user ID, right? Because now we're just partitioning really per user. Every user has their own partition, and then the partitioner sort of like distributes those partitions quite randomly across all the cluster. So you wouldn't have very large partitions, and you wouldn't have very hot partitions either. Okay. The clustering column, we will come to this as well, has an additional benefit. It allows you to sort your data. As you said, we have this chunk for the partition, right, where we have the rows within this partition. So we have New York, and then we have Adam Smith, and we have the email address. And the clustering key allows us to sort descending or ascending, for example, on the last name, right? So then we have all the Smiths in there, and then all the, you know, we can have them all together, and then alphabetically the next last name in New York, and then also on the first name, right? So then we can sort on the first name, and then we can sort on the email. So this is an additional benefit which we'll be using in our exercise today. Okay. Now, to touch on what Cedric alluded to, partitions, partition rows, large partitions and hot partitions, basically. So I think we have some good examples here. Let me just go. So we don't want very big partitions, and we don't want very hot partitions, right? So the primary, if this partition key is a good example, as we said, because you're distributing your whole users across the cluster. This one is a good example where we say, okay, for every video, we're storing the comments as well. So if you have we have uniqueness here, we ensure uniqueness. And, if the video is not too popular and attracts millions of comments, then this is probably quite good. But for example, here, if we use the country as a partition key and then put all the users into that partition, if you think about the comparison between India and Iceland, where we would have all the users from India in one partition and then all the users from Iceland in another partition, you see that you could end up with quite unbalanced partitions. There some are really large and some are really small, and some are perhaps too large, and that they come to a size that you find difficult to manage.
So on that, I do have a comment regarding also some comments on the chat. So as you might notice, it's very important to very well define the primary key based on what your query will be. You need to know that you will have the video ID and eventually add the comment ID to filter. So it might not be easy at the first approach, but in Cassandra, you tend to have one table per query. And if you do have multiple queries to access the same data, then you will have multiple tables and the data will be duplicate. Totally fine. Cassandra is a NoSQL database. So you simply have to think not like a relational database anymore, but really duplication, denormalization, totally fine. This is a trade-off to be able to request fast gigabytes of data. Cassandra is famous to be very fast on read and write and be able to have a lot of nodes, so a lot of data. So for instance, it's now quite famous that Apple is probably one of the biggest users of this technology, and Apple have 175,000 nodes of Cassandra running for a total of 12 petabytes. Probably not on the same cluster, but still that means how much you can scale, how much volume you can have in for specified data. So trade-off to keep and to stay fast, design your table for the queries.
Yeah, we also don't want to go to 175,000 nodes in order to get a row from each, right? If you want to get the data back in our queries, right? And that's the idea about that we partition the data in such a way that we can just get it back in one swoop. We don't have to go to different nodes in order to assemble it.
True, so you can understand. So it's a distributed database. You do have multiple nodes in the same cluster. What happens if you do select star from the table? Well, you will do something called a full scan cluster. So now every single node needs to give you the values and you need to aggregate everything in a single place, go back to the client. It's not a good pattern. In Cassandra, you want to avoid doing select star. You want to always provide a where clause, and in the where clause, you provide at least the partition key to be able to go to the proper node immediately and start working with that.
Good. Okay. Any other questions that are coming through so far?
Not yet. Alice is on all the questions. We can
move on.
Oh my
God, Alice!
Thank you, Alice.
Right. So we want to store together what we want to retrieve together in our partition, right? So this is very much what Cedric just explained. And so, for example, here is an example. If you want to open a video and we want to get all the comments in a single query, but we might want to have them sorted in such a way that we see the most recent ones first, right? So this one is a good primary key for that. So we go to the video ID, that's the partition. And then within the partition, this is already sorted by the timestamp. and then we have all the comments that are, for this video. So it's all together. We can just go in there and give me everything for this video ID, right? And then in the, this is a bad example here, where we say, we go to the comment ID and it gives me the created, but we don't know for which video, right? So if you still want to get to all the comments for this video with this kind of table structure and primary key structure, you would have to go to lots of different comments in order to assemble them to get the complete view of the comments of the video. Right? So we want to store together what we want to retrieve together. So always think about that, right? So it's really, really, really important. So that also means, this is another really important design principle in Cassandra. It means that you need to know what you want to get out. You need to know your queries, right? You need to know your application needs. What do you actually need to get out of your database? So this is why it's really good for admins and developers to work together, right? So that that you understand how the database needs to be laid out in order to help your developers get the best performance out of the database. Then we want to avoid the big partitions, right? So there is actually no real hard limit about how big a partition can be, but you will probably get into operational difficulties if they become too big, right? I used to work in support at DataStax, and I've seen partitions of huge sizes because they all had to log support tickets because it caused issues. So we say, stay under 100,000 rows per partition, just for as a rule of thumb, which sort of translates roughly, you stay under 100 megabytes. That is really a good measure for the partition sizes, right? And again, the country with user ID would probably potentially, depending how many users you have, give you a very large partition and quite an unbalanced partition. And this one is probably much, much more balanced here. And, you need to really think about it, what could happen with the application. For example, this is an example of an IoT infrastructure, Internet of Things, where you have lots of hardware sort of like feeding data back to a sensor ID. And if this happens at every second or every 10 seconds, you can see that the sensor ID partition would actually grow quite quickly, right? So you just let it run for a month and you would have quite a large partition. So in this case, you probably want to implement something that allows it to store it into smaller partitions, like, for example, sensor ID and week or sensor ID and day, so that you get it per day. So you keep the partition size to a manageable size. But it's something to think about. So you have to model it and you have to think a little bit about it and extrapolate how would that look when you let it run for some time. These kind of problems can sometimes appear much, much later on into the application, but the application is deployed and it's been running fine, and then suddenly you get all these problems because your partitions become too big. And so that's what that just basically explained. We want to stop the growing partitions. The other, what Cedric alluded to, was that we want to avoid the hot partitions. We want to avoid that it is one partition that gets hit all the time, because that could overwhelm the nodes, in order to serve the data back to the client. So we want to make sure that it's sort of like equally distributed across the cluster as much as possible. Okay?
Yeah, so again, to avoid hot partition mean do not make them too big, because otherwise you keep going to them because it's always the same data, and pick a value that have a partition key that have a lot of values to evenly distribute those values among multiple nodes.
Yeah, exactly. I mean, like, if you only have, for example, 5 sensors, there's no point just having 5 partitions in your database and they're all really large, right? So just break it down into lots of smaller partitions, so it's easier to manage that. But it depends on your application as well. Good. So you're ready for another exercise, and we're gonna use Astra to create some tables.
I am. So let me copy the same link as you have on screen in the chat. So yes, it's now time to create a table because you do have the proper rules to create the primary key.
And we've given you all the instructions, right? So basically we're going to use the CQL console. So I show you that here. This is, oh, I should go back into my database. Where is the, there's my killer video cluster. And then you go to the CQL console here. And then you use it, you log into this one with your password. User first, and I don't take a bit of time. I know why that is, because I enabled some additional products in my Astra, which is I hope I didn't make a typo. Wonderful. I often make a typo at this stage. But yeah, so if you get a typo, it just sort of says, so you're disconnected and you have to log into this again, into the CQL console. But this is what you should be seeing. So this is the so-called CQL shell, right? The CQL shell. CQL stands for Cassandra Query Language. And you see I've got my user, KV user at CQL shell. And this is going to be our interface to explore the database. And what we're going to do here first, so once we're in there, we can look what key spaces we've set up, and then we're going to use the key space that we created. In this case, I created killer video as per the instructions. If you use something different, then you might have to use something different. So I show you here, if you do a describe key spaces, I hope my console is visible and the font isn't too small. So you have quite a few system key spaces, don't touch them, and you use the killer video or whatever key space you set up, and then you're in the, you see it here in your prompt that you're in this key space. And if I do a describe tables, is empty. I could also do a describe key space. And I see that this is the key space, how it's set up here. It's in the free tier. It's set up with a replication factor of 1. So this is all what is expected. So you could play with that a little bit. And so what we do next, we're going to create a table, right? So we're going to create users by city table. So you can just copy this out of your GitHub. It's easiest. And just paste it into your CQL console.
Yeah, true. So we are moving from one tab to another just to do that. Yeah. Let's see if you can keep up. If we are going too fast, yeah, say us to slow down.
Oh, don't do it yet. I'm just showing you what I'm doing.
Oh, right, okay, that's me. You know, you said, okay, I'm also confused. You show exercise, so you know.
Yeah, no, I'm just showing you quickly what I'm doing, and then you can do it by yourself.
Oh, okay, so
right?
you do and they do. All right.
Yeah, exactly. And then do a quickly describe tables, so you don't have to type. I usually type it out in full.
Yeah, but that's cool to see. Tables. Yeah, just to see what would happen.
Or you can use the up key, right? It's also quite nice if you want to get to a previous describe tables. You want to get to a previous a command. And now I have users by city. And I can also describe this table. I can do a describe table users. It actually finds it with a tab. It's an autocomplete. And then I do a semicolon. And it shows me the whole table, how it's been set up. And you see it set up a lot of additional things there, like the table options, which are by default. So you do not need to worry about them, but you can later, right? If you want to do something specific in your, you have the option to set all these options, but we're not going to do that today. So the defaults are absolutely fine, right? But you see here that we have the clustering order, we're clustering by last name, and by first name and by the email, and it's all ascending, which is the default, because we specified these columns in our primary key as clustering keys. Good. And I think that was probably it for the exercise. So I'll let you do it yourself. So start at step 2B. No, probably a little bit further. Step 2A. Navigate to the SQL console and log into the database. And let's see, I give you 10 minutes. How about that? So
10? Wow, that's generous.
Now let's see. We can obviously resume earlier,
Okay.
So but
let's see which music I have for you. I don't want to. Okay, so let's see.
And let us know if you're done. Give
Sure.
us a thumbs up
or if the music is too loud or anything. Yeah. We don't have the feedback loop, so.
If you find it hard.
Oh, they are so fast. I think they did the exercise with you because.
Oh, I see.
Okay.
I didn't make it clear, right?
So the music is too loud. All right. Jason Matthews is just too fast.
Can you kind of keep tabs on how many people actually do it? You have to, just be.
Just going too fast.
It's so wonderful when we have people doing it with us.
Yes.
Doing the work. It's.
Done. Wow, so fast.
Oh my god, it's so cool.
So you can see.
When we did this 2 months ago, there were a lot more hiccups getting it set up, etc. on Astra. So we've definitely improved that. So that's wonderful.
Yeah. So in the meantime, we do have question. Very interesting question. So first is a command to create a key space. So I could give it to you, but in the Astra software as a service, the way to create key space is through the UI. So if you go back to the home page and see action, add key space. And I don't think you can do that in the SQL SH. And the reason is we won't let you all the options to create a key space, replicate the data 100 times. We are shaping the key space in a way that will fit well with the software as a service, just to be sure that the service will be live. So as you can see, Bettina go on the home page, and here on action, if she click on action, you will see that she can add a key space. But then if you are using Cassandra at home, the command is simply the one you get when you do describe key space in the SQL console. You will get exactly that. Create key space if not exist, name of the key space with replication, and you provide the value.
So I think one thing you want to bear in mind that because Astra is Cassandra as a service, it has certain guardrails, right? In order to make sure that you do not really exceed, predefined allowances or do something which would be detrimental to the performance. So it puts certain limits in place, right? So it's kind of an opinionated installation of Cassandra, especially in the free tier, right? So something that you want to bear in mind. You have more flexibility, but with great flexibility and comes a great responsibility, right? So I think we found actually a really good compromise how it's being set up in Astra, and I'm not sure you can create your own key spaces through the console.
Yes.
And
this question keep coming. So we first, for instance, we have a question about can you use master-slave architectures with Cassandra? And the answer is no. Cassandra is masterless. In a cluster, you do have multiple nodes. Each node is in charge of a chunk of the data, and the data is replicated. That means you can lose any of the nodes, not a big deal. Cassandra is often used because, no downtime. You can lose any of the node and the data is still available. So no master-slave.
Yeah, so the answer should be really, you don't have to. It's amazing. It's peer-to-peer.
Yeah.
It's flat. It's a flat hierarchy. Every node can serve requests. They can all serve read requests, write requests. Every node, right? It's even if the data doesn't sit there. So that's Cassandra is really special in such a way that they are all equal, right? In terms of how you see it from the application, all the nodes are equal and they all have the same capability.
Sure. Good interactivity. Question keep coming. So I do have a question here. What are the best resources to benefit from Cassandra except at DataStax Academy? So DataStax Academy is really strong with a lot of online courses already. I would add maybe DataStax community, which is a forum like kind of Stack Overflow for Cassandra if you do have specific questions. The GitHub, you see that we do have a lot of sample app over there. And if you still want, more, Jeffrey Carpenter, working at DataStax, released the Cassandra, the Definitive Guide book, and that's a pretty good material as well.
And we actually have our dev space, right, on our website, where we have a lot of Katacoda examples now, where you can really code along and try it out and it's using a Cassandra instance. While you do that, you can also connect to Astra with Katacoda. So I think it really depends on your learning style. So what you want to choose, right? If you like to consume a lot of videos and do some quizzes, then the Academy is right. But if you want to do it learn by doing, right, I would recommend that you go with set up your own Astra database, create an application, and practice with Katacoda. How are we doing with?
We do have a lot of people already done, so you can still play CQL command. Okay, so what else? What is the code pattern to check if a row already exists? Well, the idea is to select, providing the full primary key, and see if you do have a result or not. This is how the driver will work. You can say result.1. If it's empty, the data is not there.
And also, you might not have to do that, right? Because if you want to check that the row exists before you write into it, you can just write into it, right? So you can if you write all the values, it will overwrite all the values. So this is this is an important concept about performance in Cassandra, that you do not need to check what is there first, in order to write it, right? So it's just write. It writes very fast, and there is no read before write necessary in most cases.
That's really different for RDBMS. And again, another question: in comparison with RDBMS, do you use more space? Do you use more memory?
Yes.
You should consider Cassandra when the data does not fit on the single machine, and then you need distributed database, and then you need NoSQL. Maybe it's a shortcut, but that's the way of thinking. So the data is replicated multiple times, so it certainly takes more space on disk. When it comes to memory, you will store only memory, only the latest record, and after a certain period of time, this record will be flushed to disk. So it all depends on the specification you have. It's not like the cache in RDBMS. So I would rather say it's about the same memory consumption. If you want to install Cassandra, which you don't have with Astra, consider 2 GB of RAM and 1 TB of disk per node. This is about the sizing you can have.
So Cassandra is really a database for the more modern times, where you can have a lot of servers, commodity hardware, right? You can have a lot of them, and it's taking into account that storage is much cheaper than it was, for example, 20 years ago, right? So it's probably cheaper to duplicate your data and make sure that and run it on commodity hardware and secure your application and the availability of your data in such a way that it can survive when a couple of those servers are down. right? So that's sort of the philosophy behind Cassandra, right? It's for cheap commodity hardware, but you duplicate your data in order to overcome those hardware failures, right? So that it's always available.
Sure.
Rather than having one specific expensive dedicated node, and that goes down, and then you have no access to your data at all.
All right. Okay, so I think most of done. We're almost done with the timer. Last question I had is what about backups with Astra? So the best answer is it's a software as a service. So you don't need to worry about backup. We are doing the backup for you. And we're ensuring the SLA. So we will ensure you that you won't lose data. So we set the replication factor, we set the backup period, and we also set the
the restore if necessary.
Yeah, how many requests you can execute at a time, even if we are doing backup at the same time. But now, for backup in the open source world, there are some free tools like Medusa by the last speaker, now part of DataStax.
Yes, exactly. So the last pickle is that released kind of a couple of really good tools, for repairs and for backups. But as Cedric said, this is not at all applicable for Astra. So you don't have to. This is part of the operational overhead we're taking away from you, basically, and make it easier. So you don't have to worry about that. But yeah, if you deploy it on premise or in your own sort of like development setup, these tools are available, and you can definitely take backups and restore. Good. Should we move on then?
Sure.
Go to data modeling. Good. The art of data modeling. So I think we've sort of like we don't want to make it too complicated, and I think we've already touched on quite a few of those things. So some of the things we've already introduced as part of this workshop, and just go a little bit deeper into these and sort of group it more together. But relational data modeling is very different to modeling for the NoSQL Cassandra. So, in relational data modeling, you look at what your data is, right? What you have, you identify entities, their properties, how they belong to each other, and then you design tables with the aim of keeping only one copy of the data, basically, right? So, have sort of like almost atomic units that you can use later on to compose your more complicated data structures that you want to give to your application. And you use that with joins, right? When you sort of join the normalized data from multiple tables together in order to get your full application context that you want to give to the application. So it's a view that starts with the data first, right? Because it came from minimize the storage requirements, optimize, what's the most optimal model in order to serve all sorts of applications with the same data. And NoSQL is very, very different, right? So part of it is, as you said, is historic in a way because, storage is much, much more available, it's much cheaper. And we use hardware, that might require that we need to have several copies of the data anyway. And then also it's sort of like a different way of thinking about serving the application and keeping the performance of the application in mind, right? So data modeling for NoSQL starts really thinking about what are the needs of the application, right? And ultimately that's the end user, right? What is the need of the end user? And from that we identify, what are the workflows, what are the dependencies, what belongs to that, what are the queries that fulfill those application workflows, and then knowing the queries, what are the tables that would allow us to retrieve the data in as little time as possible. And that's what's leading towards this denormalization, where we have the same kind of data elements grouped into different tables because we have different queries that access the data in different ways and as part of different workflows. So we have the data much, much more duplicated. We might have it duplicated for different replicas, but we also have it duplicated in different tables and with different significance in a way in order to serve the query. So it's quite a different concept. And that's where it's important to work closely with your developers so you understand, if you're on the admin side, or if you're on the admin side, you might really want to really understand how this is translated into the physical location on disk, so you understand how to get the best performance for your application. So it's a little bit more of a holistic view there. And so this is with normalization. It had the aspiration to have have it only once in your database and have very simple writes, right? So that makes the data integrity very easy, right? You just have the employees, for example, in this example here with the user ID and first name, last name. And then you have here another table which has just the departments. And if you want to find all the users in the engineering department, then you have to join those together, right? So you pull the data from here and then you pull the data out of this table in order to create that view. And that results in slow reads, complex queries. They can, go, if you think about a recommendation engine or something like this, like for Amazon or for eBay or something, that imagine the complexity, how many different tables you would have to contact in order to build up that kind of view. So it's and combine it with the expectation of the user experience that we want it now, we want it immediately, we want to have it there. So it's those pros with the simple write and with the saving disk, etc., might actually perhaps no longer be as important, right? Because and then sort of like outweigh of the cons. Versus denormalization is where we have the very quick reads and the simple queries, right? Because we're storing here, we're storing here everything together, and we're storing in several places. But it means that we have multiple writes, and we have the application has to manage the integrity of the data, right? So if I update one table that has, for example, data about the engineering department, and then I update another table which has also the data about the engineering department, I might want to do that at the same time in order to ensure the data integrity. So, but in the Cassandra world and the applications that we know from Cassandra, what do we know? For example, we mentioned Apple, we have Spotify, we have eBay, we have actually quite a lot of banks. We have a lot of really, I think, in the entire online world, you deal with applications that are powered by Cassandra every single day, where these are the things that are really important for the end user experience. You have the quick read, right? And you get the simple queries. Do you have anything to add to that, Cedric?
Nope. We got a lot of good questions. I answer live.
So,
yeah.
Do we need to stop?
No.
No. Perfect.
Everything's fine.
Good. So this is not necessarily an easy task, right? I think it's something that requires a little bit of consideration to come up with a good data model, and you might want to, and that's why we call it a little bit the art of data modeling. But there is a process which allows you to, if you follow it, I think has a good, should give you good results, to think about what your data model needs to look like and what the tables need to look like. And here we're going to take you through the process with some simple examples here, but you definitely want to make sure that you know what are the entities that you want to give to your application, what are the relationships, and what are the queries, that you're quite clear, right? So I think the best success for data modeling in Cassandra is that you're quite clear about the queries, right? So you're quite clear what the application wants to retrieve, right? And you obviously express those queries within the context of those entities and relationships. So, for example, so we have the use case of users commenting on videos and videos being commented on by users, right? So these are our entities, and these are the relationships. And for example, the user, we identify them by a user ID, they have an email address, they might have additional data like profile data. And then we have the video, we have the ID of the video for its uniqueness, we have its title, we have its description, we have lots of metadata or something like this about the video. There could be quite a lot. And then we have the comments, they're grouped, the timestamps, so we can retrieve them in a certain order. And then obviously we have the comment body as well. So with everything that is, there might be additional things in the comment, or comments of comments, whatever. So this is the data we need to deal with, right? This is the conceptual model that our application deals with. So, oh no, you're on mute, Cedric. Oops. Cedric, mute.
I'm here.
You're not on mute. That's why I could hear you.
Oh, you can. All right.
So the design process is that you think about the application workflow, and you think about what does my application need to do with this data, right? So for example, here workflow 1, I want to find all the comments related to one video and want to display the most recent first, just the last 10. Or another workflow, find all the comments related to one target user and get the most recent first. So these are two different views of the same thing in a way. It's all about comments, but this one we group them by the video, and this one are the comments, we group them by the user, right? So this could have comments about lots of different videos, and also a video could have comments of lots of different users, right? So we already will see some duplication of the comments. They will be in different tables because they're in a different context. They belong to a different workflow. Make sense? So we then come to the queries, right? So we articulate the queries based on that. So find all comments posted for a user with a known ID and show me the most recent first. And that makes the comments by user. Or the second query that we have is find all the comments for a video with a known ID and show me the recent first. And that's the comments by video. And if you express that in SQL, in Cassandra query language, that would look like this. Select all from the table comments by user, where the user ID matches a certain value. Or select all from the comments by video, where the video ID matches by a certain value. And so these are our queries. And from that, we construct the logical data model, right? So what does our table need to look like? So we have the user ID. That's going to be our partition key, right? And we have the creation date and the comment ID for the uniqueness, right? So all those three will ensure the uniqueness of the comment, and the creation date will allow us the sorting by the most recent first. And then we have the same for the comments by video. We have this time it's grouped by partition by the video ID. And then in there we have again, the creation date and the comment ID. And again, we have all those three for the uniqueness, and we use the creation date in order to allow us to sort by the most frequent first. And then, of course, we have all the other data that we want to pull, really. We want to pull the comment itself, right? This is just how we're going to select the data. But this is really what interests us, and same here. Okay. And then we come to the physical data model, where we want to make sure exactly what types are we using and how are we storing this disk. So we have the comments by user. For the user ID, we're going to use a UUID. This is a very nice unique identifier. You can generate this with Cassandra query language. You can generate it with the DataStax drivers to ensure a unique ID of your user. The same for the video ID. And for the comment ID, we can group those creation date and comment ID into one by selecting a time UUID. So the time UUID is a type 1 UUID that has a timestamp within its UUID structure. So that has the added benefit that you get instant uniqueness for this UUID, but also you can sort it by time. So we can already have, the sorting. So we have the uniqueness in there, and we can have the sorting. So we can optimize this a little bit here and the same for this one. And then for the video ID, we just use the UUID assigned for that. And for the comment, we use a text column, so which is freeform, right? It's not limited by the number of characters. You can put, you know, quite a lot of data in there. I think I don't exactly know what the limit is, how much you can put into a single cell, but it's definitely, I think it's something like 2 million characters or something like this, or in this area. So I stand happy to be corrected if anybody knows the answer to that, so the exact limit there, but it's not anything like 256 characters or something. Yeah, and that gives us our schema. So from here, so we basically here, this is the comments by user, user ID, comment ID, video ID, comment. These are our columns and our types. And from that, we can totally construct our schema. So we have the comments by user, user ID, comment ID, video ID, comment text. And then we know what our primary key needs to look like. It's the user ID, that's our partition. And it's the comment ID, this is our clustering key. And then we can define what clustering order we want to have. And in this case, we want to use, because we want to get the last 10, we want to display the most frequent comments. So we go for the descending order. The default is ascending. So if you want to just show the most frequent ones, you want to override that with descending here. And that's going to be the table. Okay. Right. Time for you to try it out. So this is the exercise 3. Let's go to the Aster page.
Okay.
And have the GitHub.
Yes, let me copy part number 3. Okay, CRUD. All right.
CRUD. So
create, read, update, delete.
You're gonna create the table. So again, you don't have to do it at the same time as I do it. So I just show you a little bit.
First you show, then we do with lovely music.
I show, and first I show you what's in the GitHub, and then I show you in Aster. So first you're gonna create the tables, and we're gonna describe the tables and look at them in Aster, and then we're gonna insert some data. You know, make it interesting here. So so we have the insert statements here. We're gonna hard code the UUIDs this time, in order to make it easier for us to look them up again, right? Because otherwise this becomes quite difficult. And then we can read them, we insert some more data into the other table, and then we start reading the data. And I think we can probably also update some data, and we might even delete the data in order to show you the whole CRUD flow. Okay, so let's go to Astra and see whether I'm still logged in. I'm still good. This expires after some time, so if you've waited too long, but this is still good. So let's have a look at creating the tables. So it's very simple. You just copy them, put them in there. Make sure you use the killer video key space. So if you logged in and out again, then you might have lost that. Make sure you use the killer video, because I don't think we specify it here. You could also specify it here, create a table if not exists, killer video dot, right, in order to do that. But if you don't, you get an error. So these are our tables. Let's have a look. What tables we have. And we have comments by video, comments by user, and we still have the users by city. We actually don't need that anymore. Actually, we can just drop this. Drop table users by city, and so we don't have that in our key space anymore. Okay, so if I look at the tables now, I only have those 2. Okay, so let's insert some data, and again, copy that all out. We can do it step by step as well. So I think I show you. I mean, let's go through the command first. Insert into comments by user. So first we're selecting the columns that we want to insert in. So we use user ID, comment ID, video ID, comment. You don't have to use them all, right? But you should update all the columns that are part of the primary key. So you would definitely have to update the user ID and the comment ID. And then we have just the values, so this is for the user ID. Then we are generating time UUID with now, which is a SQL function that generates your type 1 UUID, so you do not have to do it yourself. And then we're giving a prefab video ID, right, which is we've made very simple so that it's you can look it up again. And then here, so this is our comment, and this is David who created this. And then very similar here, we just insert some additional data. It's all the same format. We tell it which columns we're going to update, and then which values we insert for those spaces. And again, we use this special function here in order to create our special timestamped UUID that we can then use to look up our sort our comments. Okay, let's do that. Let's copy that and put that into Astra. Okay, and now we do a select star from comments. I can auto by user, autocomplete with tab, and there's my data. So that was simple. Okay, and you've got all these different comments here, and then let's quickly insert some data for the other table. So in the comments by video, those two. Okay, and let's have a look at this one. Video.
Cool, you do have the auto completion.
Yeah, you didn't know that?
So, I'm not sure.
I use that all the time. Yeah, no, it's very useful actually. So, okay, so now let's start reading. So this is reading. Basically, if you do a select star, you could say it's reading, but we can be a bit more specific. We can read by a specific video ID, for example. Right? So we can say select all from, and then there we say the video ID equals, and then I think we may have to do it. I always keep forgetting. I think I have to wrap it in quotes. Let's see. No, I don't. So
no, because UID is an object.
Yes. Oh, that's
not a string.
That's a good answer there. Yes. So this is how you would read, right? And if you have a lot of them in the same partition, do we have a couple? I think we will have all different partitions in this case. But here we have a lot of them in the same partition, so we can retrieve with one swoosh all the rows for this partition. Let's do that. So let's copy this long partition string here that I have. But this is the one here. And select star from, and I do the comments by user there, and I think it's comment ID. Oh no, it's user ID. User ID equals this one. Oh, no, I made a mistake there. What is the user ID? And is that nothing? What was that? Oh, I must have copied something funny here because that doesn't look like the full UUID. So
1, 2, 3, 4, yeah.
So, yeah, I copied something odd here. It's copying. That's the same.
That's the problem of, yeah, one so we're missing. So now I think you're good.
Oh no, yeah, exactly.
Yeah, you do have a one, yeah. So, next time we should use letter as UID.
I know, yeah.
ABC, ABC, right, ABC. Yeah, it should be, I think it's 8, 4, 4, 4, 13 when you build a UID.
So you have here you have the example that I just gave the partition key and I pulled out the whole partition chunk, right? So I could also now be more precise, right? I could say I want to get the partition and I want to have the comment ID equal to the, this one here. And that is the clustering key that ensures the uniqueness, and now should only get one row back, right? So this is an advantage, right? The partitioning. So you could, if you partition your data in such a way that where you have the use case where you want to retrieve quite a few rows with one swoosh, make sure that they're in the same partition, right? And then they should be ordered by time here with the comment ID timestamp. But also, if you want to get to just one row and that, you have to specify both of them, right? You cannot just go in there and say, I'm only specifying the comment ID because that gave me the uniqueness. If I do that, it will actually complain that no partition key was specified. So if I do that, you get an invalid request error saying you need to, you cannot run this query because you didn't specify a partition key. Okay, so this was the reads, and this, I did not touch here. And then we just do some updates, right? So we want to overwrite some data, basically. So this is how it works in Cassandra. In order to update, we just go back into the same row and we just write the new value. We do not need to select a row first in order to write the value. We just go back in the same row and we write the same value. So in this case, we can just use here. So okay, so I think probably should copy because I don't make too many mistakes here with the so let's insert this one here. So, and
oh my god,
insert.
Oh my god, Patrick's such a geek.
Oh my god,
who wrote that comment?
Exactly. Oh, I think it was Eric. So, and then if you want to override that, so we can just go and just, I think I should probably have prepared that in a different way. In order to update this, where is the update command?
Update, yes.
Oh, so this is just the update. Oh yeah, update. Yeah. So there it is. Sorry, that's the update. Comments per video. Set commands. And I was looking for a different command. I would have done it with the insert and just write it again, right? So if you look at it now, so select star from comments by video, where video, oh, actually I should just show you in 6star because I don't have that much data in here. So you see God, that guy Patrick is on fleek. I know, whatever that is. I'm not sure whether that's something nice. But so you could, I think I would actually like to create you a different insert statement as well here. So insert into.
Oh wow, no copy paste. Let's see.
Yeah, exactly. By video. Actually, I should sort of think about, so I think I want to specify the video ID, right? I want to specify the comment ID, I want to specify the comment, and I want to specify the user ID.
Okay. And
then I do the values, right? And now I put all those things in. Let's do this one here, right? So have the value here for the video ID, then have the value for the comment ID.
Still no quote because UID are already objects.
But now I need quotes, and now this is
because now it's a text.
Single quotes, because otherwise SQL would not like this, So
that's part of the syntax.
How about that? So
on fire? No, not the proper term at the moment.
Oh no, it's not. No. Yeah, it is. It's fine.
No. Patrick's live in California, where we get all this trouble.
Yeah,
he is.
And do that.
Right? Oh, okay. So you want to? Okay. You only change the comment then. Everything is the same except the comment.
Yes.
So the primary key already exists, right?
The primary key already exists.
So what we should have already exists exception?
Yeah. No error. So good. I can do this freeform. And now look what happened. We've overwritten the row, right? We exploited the uniqueness, right? We inserted again, into this unique row. We have the same partition key and we have the same comment ID, and we just wrote a different value into this, right? And so Cassandra only knows one place to put this data, and this is defined by the video ID and by the comment ID. We use them, so we overwrote the row, right? So Cassandra didn't even check first whether the data exists, right? It doesn't do a read before it does the write, right? So it just overwrites it. This is a really important concept because this is fast, right? But you might also want to bear this in mind when you write the application, that you write idempotent data, right? It can stand by itself, right? You provide the whole context. So you do not need to rely on subsequent updates in order to construct the state of your data, right? Because you might actually end up with an impartial state. So it's something to bear in mind. But this is a really important concept about Cassandra as well. An update is just another insert. You just write the same data again. Okay, I think I'll give you, we can also delete it. Let's delete it, right? So it's delete this statement from, we have it, comments by video where, and now we want to be really specific. We want to provide the unique row, right? So we want to where the video ID equals, so we need to give it a partition key, and we want to give it a comment ID, right? So that we do not wipe out the whole partition. And so we'll do that here. So okay, and let's select everything again from, and it's gone. So the data is gone. So we've created, we've read, we've updated, we've upserted, as we say it in Cassandra lingo. We updated and inserted at the same time, and we deleted. Good, and I think you should try it out yourself, right? So this is, go to step 3 and try out, play with your data, similar to what I've done just now, or you can just follow these instructions. Step 3, execute quant operations. And yeah, once we're done with that, you're gonna have the Menti, and that's the workshop. So let's see how it goes, and give us some thumbs up if it's easy or hard. Let us know if it's hard, if you want to answer your questions, and make sure that you can successfully execute these different operations. And Cedric, you want to play some music?
Sure, I will. Let me see. Boom. Not too loud. All right. Yeah, answering question about time UUID. When you want to insert a time UUID, so if you use a Java driver, for instance, you say UID.time-based, so it's generated at the client level. But then if I trigger a SQL statement and still put, UUID bracket, I ask Cassandra to generate that time UUID, and I think it's done at the coordinator level and propagate to the node.
It is.
So
because they all have the same value, right? So all the replicas have the same value, so it must be done at the coordinator level, right? But this is an important distinction, isn't it, Cedric? Because your client clock might be different to your server clock, and so you could have different write timestamps if you're using those from the client rather than those generated on the server. So if you want to have the best consistency for these time UUIDs, I would probably say generate them on the server, so you do not suffer from lots of different clock screw across your clients that you might have, right? Because that will then determine who's the latest, who put the last bit in.
Yeah. So if you want to screw your neighbors, you put your time ahead of the others, and then you will overwrite the value from others.
Yeah, imagine eBay. You will always win. You will always be the last bid.
Yeah, that makes sense. And on the Cassandra nodes, you should have something like an NTP just to synchronize the clock of your nodes. Would make sense, right?
That's actually one of the things, again, that Astra takes away from you. You do not have to think about the way that your infrastructure really can support this distributed database, and clock synchronization is an incredibly important aspect, right? Because, you know, as we saw, we inserted the data again and again, right? So the Cassandra doesn't actually delete the data. It just it stays there. It just overwrites it with an additional row. And then it selects based on the latest value, on the latest row that was put in for that primary key. So it will compare the timestamps and just give you the latest. So time is a really important concept in order to determine what is your real data in the database. And if you have a lot of different nodes, they need to be synchronized with like network time protocol, something like that. But again, it can be an administrational overhead, and you do not have to deal with that on Astra.
Okay, so question keep coming. That's great. You know, it makes the time faster when we're waiting. So a question about Anand Ray. So why do you have the error about the message telling you you should use allow filtering? So the reason is, in your query, the where clause that you provide is not the partition key, or does not contain the partition key. That means when Cassandra reads your queries, by default, it does not know on which node fetch your data. And so that's the default behavior of Cassandra. You can override this behavior by putting allow filtering in the end, and that will simply say, oh, I know what I'm doing, please do the full scan cluster. And then
exactly. Look at every row. Look at every row in order to find that comment, right? So that's what you're basically telling it.
True, but disclaimer, if you need allow filtering in your queries, you do have the wrong data model. You should not, to keep your query fast.
Yes, I think you might just want to use sometimes it in development, etc. But it is wrong. I mean, just imagine it. It will have to look at every row so it doesn't scale, right?
True.
It is slow. It doesn't scale. So, right. Yeah.
Okay, next question is, what type of application Cassandra best suitable for? So for this one, I would say, what are the strengths of Cassandra? First is highly scalable. You can add as many nodes as you want in a ring, and it will scale linearly. So all the applications that need a very high throughput in read and write, or need to scale very far, Cassandra fit those use cases. Data is replicated among multiple nodes, and no master, so you can lose any of the node, not a big deal. So use case when you do have your data that do not allow any downtime, and even when you do updates or upgrade, you will do running updates, running upgrade, shut down a node, upgrade everything, put it back online. Nobody noticed anything. That's the beauty of distributed and replicated. Then I add companies with data all around the world. So in a Cassandra cluster, you can have multiple rings. So you can have a ring in Europe, a ring in America, a ring in Asia. Every read and write you are doing on a node can be replicated asynchronously on the other DC. It's not your job to do so. So now you can have DC all across the world and have a global database, or DC in one cloud or another and have the same data layer available in all the clouds. It's all about multi-cloud, hybrid cloud. You don't have to copy the data. Cassandra do it for you.
Yeah, and I think there's so many examples where Cassandra is a really good use case. For example, everything that you want to support really fast writes, have a lot of data ingest, etc. Cassandra is a really good database for that, for example. And as I said earlier, you probably in your daily life, you probably touch Cassandra in so many ways, right? I mean, if you sort of think eBay and online shopping, right? Spotify. These are really famous examples, you know, but a lot of banks use it. And I personally sort of think, you know, with the introduction of Astra, you don't actually have to just reserve it for the high performance and super scaling applications. You know, even small applications work really well, right? A small online shop is perfect.
Oh yeah, totally. You know, that's the biggest strength. But they say replicated, distributed, that scales. But now on top of that, you can have any kind of, you know, real-time application, to be honest. Matter of fact, we do have some big companies using a data lake, you know, big data, Hadoop kind of technologies, and using Cassandra on top of it as a layer to access, read and write fast. Cassandra first could be all about OLTP, very high throughput, very high volume, but also you can have some DC very dedicated to OLAP queries, and so you can use tools like Spark to do some aggregation. And so now in the same cluster you have one DC, so a bunch of nodes dedicated for LTP, a bunch of nodes dedicated for OLAP. Those won't have the same hardware specification, because OLAP maybe you will put a lot more on CPU, and OLTP more on SSD or RAM. Yeah, true. Yeah, so very wide range of use case. And we will make it even better. So our goal is really to ease as much as possible the access layer to Cassandra. So you can see in the Astra, as of now, you do have the REST API, you do have the GraphQL API, and we have announced this week a new open source project called Stargate, and this will allow document API. So cool.
How we're doing with sort of the exercises? Is it smooth sailing? Do you see a lot of problems or thumbs up? How's it going?
No, I think people just playing with SQLSH now. I only have the tricky question popping now. There are people just on the screen. Yes, I think they're done.
Oh, perfect. Okay, well, that just gives us enough time to go for the Menti quiz.
Oh, so wow. So now I need to change music, because now we need to get serious.
We need to get very serious. Right, so let's stop this.
Competition, ladies and gentlemen.
Okay, so let's go to Menti, guys. So, where is my Menti? It's here. Okay, so it's the same Menti code as before, and I should have put the QR code in there, and I didn't.
No, that's so okay. Again.
Hopefully you stayed on it, right? And just, you know, now it's timing. Now you need to be fast. You need to answer fast in order to get into the top 10. And make sure that you look at your phone. Don't look at the video, because at the YouTube, because it's a bit slower, right? Look at your phone for the questions, so we can see it all. And
as fast as Cassandra. What a nice comment. You need to be as fast as Cassandra to get your points.
So how many should I wait for? I see 31 so far. How many should I wait for?
Yeah, let's wait 1 or 2 minutes more. I see a question regarding delete. So is delete part of what's coming, or should I just say, to be honest, when you delete something in Cassandra, it's not really deleting. We just add a new line telling the data should not be there anymore. It's, you know, happened only. This is what we call a tombstone. And once in a while, there is a process running in the background, removing all these data and the line telling that data is deleted. So be careful if you are, shortage of space and want to delete something in the table. If you simply say delete from the table, you will get even less space, because it will simply add a new row telling you, oh, you should delete everything in the table, called the tombstone. So you can do that using truncate keyword. But that's a good question. And you can delete either a row, or you can simply delete a value inside a column.
Oh, you can also delete a partition.
Oh, true.
Right? So
Yeah.
you can. So you have the same flexibilities in a way that you have for reading, right, and inserting. So it's just another insert, as Cedric said.
Okay.
And so you have those same flexibilities.
Okay, I don't know if the music would be serious, but it will be fun. And it's free of copyright, so let's go. I think you will guess what it is.
So Cedric, do you need to do anything else for starting the Menti? I think last time.
Okay, so if you go to next slide.
Oh, this is the wrong barcode. I didn't update this one. So this one is good.
Yes, so that's simply telling you we will start soon. All right.
Oh.
And then if you go next, I think you will see waiting for users.
We made a mistake there. Yeah, exactly. Yeah, waiting.
All right. So now we will see players coming. Okay. So now we are waiting for players. Nothing will start until you decide to press enter. And remember, when Bettina press enter, you would rather read your phone's screen, because the question will show up much faster on your phone or on the tab you are using to answer, than on the YouTube screen where we will read the question. You will get 2-second delay. So
good. Right, I've got 57. Should I just go? So
yeah, I think it's time. We should move on.
Oh wait, answer fast to get more points. Let's see. What is a primary key? Look at your phone. Is it the same as a partition key? Uniquely identifies a row. It's a column in the partition key, or it's the main house key.
The main house key.
Right. So almost done. Time's up. And yes, uniquely identifies the row. It can be sometimes be the same as a partition key, but often you have clustering keys, etc. So this is it's only sometimes the right answer, but normally it's uniquely identifies a row. Very good. Okay, next one. Oh, leaderboard. I keep forgetting about that. This is really
yeah, who's leading?
This is
oh, that's so close. Look at that. Ashish Shada is leading, I think.
12 points. Oh my god. And between
Abhishek Argaiwat. Oh, we can.
Points.
And you know, we see all people asking good questions over there.
Coolio. Next one. Okay, so.
Jason Matthews. We see you.
See, question 2 or 5.
Okay, and then same. You press enter and they go. Okay, boom.
What? Oops.
The primary key.
Oh no! What is the partition key this time? Sorry, screw me. A consecutive number applied to each new record, a designated field in your table structure to partition your data, an optional table field for optional partitioning, or another word for the garage key.
After the house key, now we do have the garage key.
Ah, very good.
Yes.
Very good. Oh my god, people have learned! This is just lovely. And nobody choosing the funny answer at the end. So if you've been to our quizzes before, it's always the last answer that is a bit strange. You don't have to concentrate on this one. Right, let's see. Oh, what have we got here? So this is still the same. No, we have to change. Abhishek, you dropped down a little bit, but only by 2 points. It's all in there. So next one, okay? Good, you have to be fast. Everybody is fast here. This is I never make it to the leaderboard. So question 3 or 5.
Especially, yeah.
What is Astra? Look at your phone. Don't look at the video.
It's a movie.
It is a local in-memory version of Cassandra. It is Cassandra as a service in the cloud. It's a development tool. It's a gateway to the stars. It's also a movie, isn't it? You know, I think. Is it? Let's see. Ah, this was really easy. You know, it is not just a development tool. I really want to put that out there. We have quite a few customers who run it in production, right? So this is totally production ready, and it is really just another option of running it yourself.
But that would deserve a rewrite of the question. Now in Astra you do not only the DB but tools around the DB. So I'll take that on me.
Oh, okay. That's okay. All right.
Kind
so
of a data platform. Yeah, now Astra is more than simply the database. It's really a platform. Yes, Luis, it's really a movie.
Okay. Let's see who is there? I see there's some fast fingers.
Shiv was faster.
Oh, Apache, you made it up again. Look at this. Yeah. So okay, you have to be fast.
Oh, so much tension.
Okay.
Wow.
Right. Oh, this is a hard one. I remember this question. So, answer fast to get more points. What flow is used to create data models in Cassandra? So, is it data, models, application? Models, application, data, application, models, data, or create data models?
The last one is always funny.
I think that's always true. So, yay! Yeah, so again, data models application, this is very much the RDBMS, right? So the normalized data, this is really what I said.
True, we got a very accurate comment before today. It was really a NoSQL is all about really focus to the application, whereas RDBMS is more focused to data.
Yeah, exactly. Okay, so but better luck next time if you got it wrong. So oh, poor Rogue, you just slipped out.
Shiv outperformed everybody.
Still on the leaderboard. So
Shiv was just too fast.
Came out of the nowhere. So look at this. This is amazing. Cool. Okay, the next one is
So Alvaro, you said you was too slow. Now you're back in the course. Now you're second place.
What type is used to store both an ID and a timestamp?
Oh, it's
this is very small. I don't know. It's time ID, timestamp ID, time UUID, all the things in one type ID. So again, time ID, timestamp ID, time UUID, all the things in one type ID. I apologize. I didn't realize this would be so small. Oh, you got it right though. Perfect. Most got it right. Yeah. So the time UUID, I think because of the large amount of data we're pushing into Cassandra, the UUIDs are very, very useful in order to ensure uniqueness. But the time UUID is especially useful because it has the timestamp in there. And as we highlighted, we have server-side tools and client-side tools in order to generate it for you. So it's a no-brainer to use it, and it's a very useful UUID. Perfect. Cool. That was it. So this is the leaderboard. And the top 3... Let's see, these are our winners today. Shiv, wonderful. So you're the leader. Well done. So
congratulations, Shiv. Please reach out to David. Why is it David? Jack Fryer, either on YouTube chat or on Discord to get your swag.
The email address of Jack into the YouTube chat and also in Discord, so that would be great.
And if you live in India, we would need to see your ID and a paper telling you that you are agreed to get the swag back through the customs.
Okay, wonderful. Cool. So yeah, that was Menti for today. I hope you enjoyed it. You just have to practice to answer really fast, and then you will get your swag eventually, I'm pretty sure. So thanks very much for playing along. Good. So I think before we go, just let us know what we could do better.
That's the last survey, free form. Before we let you go, we will be on time almost. Yeah. So please help us with the feedback, just for help us to improve. So remember.
Tell us also, what you didn't like or something.
Yes.
Is it updating? I actually see something.
Is it fast enough? No, we just have somebody putting a point.
No comments. I don't know. Is that? I don't know whether it's updating. Come on, just tell us that it's working because it's not updating.
Do you want me to go there?
Oh, transactions. You know, a deep dive session on transactions could potentially be quite short in Cassandra because there isn't actually any concept of transactions in Cassandra.
You know, still, I would reshape that as ledger data model, good usage of LWT and batches. Would be cool. Deep dive session. Oh, on the channel, we do have deep dive session all around the place. So, yeah, we just...
So more content. I mean, we have a lot more content. So we've just done... First of all, we record all the videos, right? They're all on YouTube. So we've just done a full 8-week series that tells you from the beginning what is Cassandra, and then a special 2 hours for data modeling, and then how to write your applications, etc. So you can all still review this, and it's still all on GitHub as well if you want to go through a lot of content, right? And it depends. Let us know. You know, you can always reach out to us on Discord or on community and let us know what kind of content you're after. And then we can find some sessions for you that we probably have already done, or we take your feedback and create some for the future. Wonderful. Thank you. I think that was basically it for today. I think...
yes. Thank you to all of you. Thank you for people helping us. So Alice and Wade did a lot of answer either on Discord and YouTube chat. So thank you to them.
Thanks so much, Alice. Yeah, thank you. And who else was on there? So I can't see Discord. But thanks everybody for asking the questions as well, because it makes it so much fun. Right?
Yes. And until then, see you next week.
See you next week. Next week is Spring and Java.
Yeah.
And write an application.
All about Java. See you.
Bye.
I found someone